Have you ever imagined walking on Earth and coming face to face with an extremely horrifying creature? Forget the T-Rex for a moment, because today we're going to meet even more terrifying creatures. Dinosaurs so fierce, so gigantic and lethal that they would make anyone reconsider the idea of a trip to the past. Spinosaurus. At the dawn of the age of dinosaurs, when colossal creatures ruled the Earth, one giant stood above all the others. Neither the fierce Tyrannosaurus rex nor the agile velociraptor could rival its aquatic grandeur. Its name? Spinosaurus aegyptiacus, the most fearsome predator to ever inhabit the rivers of ancient Africa. Imagine a warm, humid world teeming with life. Over 95 million years ago, during the Cretaceous period, rivers wound their way through lush forests and vast lakes. In this hostile ecosystem, a monster glided silently through the water, hunting prey with lethal efficiency. The Spinosaurus, with its impressive length of 49 to 59 feet, was a true titan. Weighing an estimated 15,000 to 22,000 pounds, it surpassed the Tyrannosaurus rex in size, making it the largest known carnivorous dinosaur. But its most striking feature? A massive sail-like structure on its back, made up of bony spines that rose from its back. The origins of this titan were a mystery for many years. The first discovery occurred in the early 20th century, when German paleontologist Ernst Stromer found fossil fragments in Egypt. However, World War II destroyed these findings in a bombing raid on Munich, temporarily erasing the evidence of this remarkable creature. Decades later, new discoveries in North Africa brought an even more surprising picture to light. Unlike other theropods, the Spinosaurus was a semi-aquatic hunter, adapted to life in rivers and lakes. But how do we know this? The key to this mystery lay in its skeleton. Unlike land-speed predators like the Tyrannosaurus, the Spinosaurus had proportionally smaller hind legs and a more elongated body, suggesting it spent much of its time in the water. Its sharp claws and long jaws, filled with conical teeth, were specialized for catching massive fish, such as the giant coelacanths and the ubiquitous coelacanthiforms that swam in the ancient African rivers. Additionally, its dense, heavy bone structure was similar to modern animals like hippos and penguins, allowing it to sink rather than float, ideal for hunting underwater. Its snout, filled with sensitive sensors, detected vibrations in the water, making it a stealthy and relentless predator. But what was the purpose of that impressive dorsal sail? For years, paleontologists speculated whether it served to regulate body temperature, intimidate rivals, or even attract mates. Some scientists believe it might have acted as a hydrodynamic structure, helping the Spinosaurus move more efficiently in the water. But to this day, the definitive answer remains shrouded in mystery. Hunting style. An artistic reconstruction created by the W models depicts the Spinosaurus in an aquatic environment, using its paddle-like tail to swim. The elongated neural spines, combined with the chevrons located at the bottom, give the tail a deep structure. If this tail was indeed that flexible, it would have been highly efficient for underwater propulsion. However, in 2021, another group of paleontologists analyzed all the available data on the Spinosaurus up to that point and presented an alternative view. They argued that, rather than being a water predator specialized in chases, the Spinosaurus likely adopted a behavior similar to that of a heron, patiently waiting for prey. According to this interpretation, the paddle-shaped tail would not have been an adaptation for swimming, but rather a structure for social or sexual display, comparable to the tails of modern basilisk lizards and spiny lizards. Although these species are also good swimmers, their ornamented tails are typically kept out of the water, suggesting that they do not play a direct role in aquatic locomotion. The 2021 study also brought new arguments against the idea of the Spinosaurus being a submerged pursuit predator. The researchers highlighted issues related to the animal's stability and submersion capabilities, suggesting it would be limited to ambushes in shallow waters rather than long aquatic chases. The search to better understand this giant led to one of the biggest twists in modern paleontology. In 2014, paleontologist Nizar Ibrahim and his team announced the discovery of a more complete Spinosaurus skeleton, revealing previously unknown details. The theory that it was a semi-aquatic predator was reinforced, and in 2020, new studies showed that its tail had a unique structure, long, flattened vertebrae, forming a fin-like structure similar to a crocodile's. This suggested that the Spinosaurus not only hunted in the water, but could swim efficiently, an unprecedented feature among carnivorous dinosaurs. However, the life of this super predator wasn't without challenges. Large crocodilians, giant pterosaurs, and other carnivorous dinosaurs competed for the same resources. While it was the king of the rivers, out of the water, it might have been vulnerable to attacks. Its anatomy, adapted for aquatic life, made it less agile on land, which could put it at a disadvantage in confrontations with land predators like the Carcharodontosaurus, another giant dinosaur from Africa. Beyond hunting, the Spinosaurus also had to defend its territory. Large disputes could occur between individuals of the same species, especially during the mating season. Fossils found show signs of injuries suggesting violent fights, possibly over dominance or mates. The waters they inhabited were full of challenges. Other aquatic predators could represent threats in ambushes. Additionally, climate changes could alter river levels and affect food availability, forcing the Spinosaurus to adapt its hunting tactics. The end of the Cretaceous period was marked by intense climate changes and catastrophic events. The impact of an asteroid, 66 million years ago, triggered global fires, tsunamis, and a lasting darkness that collapsed food chains. As a creature dependent on rich aquatic ecosystems, the Spinosaurus may have been one of the first victims of the mass extinction that wiped out 75% of life on Earth. But its legacy lives on. Science continues to unveil its secrets, constantly rewriting our understanding of the largest carnivorous dinosaur that ever existed. The Spinosaurus was not just a predator, it was an aquatic titan, a river monster, and one of the most fascinating examples of how evolution can shape creatures in unimaginable ways. And so, amidst fossils and scientific discoveries, it continues to live in our imagination as the true lord of the Cretaceous rivers. Therizinosaurus. This might have been one of the most terrifying dinosaurs to ever walk on Earth. A world dominated by colossal predators and titanic herbivores, a peculiar creature walked among the forests of the Cretaceous period over 70 million years ago. With giant claws and a body that defied all known classifications, it looked like a monster straight out of a nightmare or a science fiction story. But this creature was real. Its name, Therizinosaurus. Originally discovered in Mongolia in 1948, Therizinosaurus cheloniformis remained a mystery to paleontology for decades. Its fossils were incomplete, fragmented, and at first glance seemed to belong to a giant turtle. This is because the early discoveries included only its enormous claws and forearm bones. But as more pieces of the puzzle were revealed, scientists realized they were dealing with something entirely unexpected. Unlike any other carnivorous or herbivorous dinosaur, the Therizinosaurus possessed a strange set of features: a long and flexible neck, a robust body possibly covered with feathers, and a pair of incredibly long arms armed with the largest claws ever recorded in Earth's history. With impressive claws measuring 27.5 inches in length, they were longer than those of any known predator, including the famous raptors and even the imposing T-Rex. But surprisingly, the Therizinosaurus was not a hunter. It was a herbivore. Imagine a dense forest filled with cycads and giant ferns. In this setting, the Therizinosaurus moved majestically, using its enormous claws to pull branches and strip entire trees of their leaves. Its impressive size of 32.8 feet in length and a height similar to a giraffe made it one of the largest therizinosaurids ever found. Its keratinized beak helped it grind leaves, while its flattened teeth indicated a highly specialized herbivorous diet. But if it wasn't a predator, what were those giant claws for? Many scientists speculate that these natural blades served as defense against large carnivores, such as the feared Tarbosaurus, which shared the same habitat. With a single strike from its sharp claws, the Therizinosaurus could inflict deep wounds on any attacker, making it a formidable opponent even without sharp teeth or powerful jaws. What also makes the Therizinosaurus fascinating is its evolutionary position. Initially, its strange appearance led paleontologists to mistakenly classify it as a reptile similar to turtles, but later discoveries revealed its true identity. It belonged to the order of theropods, the same one that includes carnivorous dinosaurs such as the Velociraptor and Tyrannosaurus rex. However, over millions of years, its group followed an unusual evolutionary path, becoming herbivorous and developing unique traits within the theropod dinosaurs. But how did such a strange and imposing animal live in the world of the Cretaceous period? Studies indicate that the Therizinosaurus was a solitary dinosaur, or at most, lived in small family groups. Its survival strategy did not rely on speed or attack, but rather on size, intimidation, and camouflage. With likely feather coverage, it could blend into the vegetation, avoiding predators until it was necessary to defend itself with its claws. Additionally, its bipedal posture and long tail helped balance its large body, while its wide feet provided stability, allowing it to move through various terrains. Its behavior is still a mystery, but studies of closely related species suggest it may have had diurnal habits, spending the day feeding and occasionally interacting with other members of its species. What really stands out about the Therizinosaurus is how little we know about it. The absence of a complete skull still leaves many questions unanswered. How exactly did it process its food? What was its real life expectancy? And what was its exact role in the Cretaceous ecosystem? Despite the gaps, one thing is certain. The Therizinosaurus was one of the most unique dinosaurs ever discovered, challenging all the rules we thought we knew about the giants of the past. a dinosaur that seemed straight out of a horror movie, but in reality was a vital piece of the natural balance of its time. The study of Therizinosaurus fossils continues to bring surprises. New scanning and digital modeling technologies allow for increasingly accurate reconstructions of its anatomy. The microscopic analysis of its bones may reveal details about its growth and metabolism, and future fossil discoveries could provide definitive answers about its behavior and ecology. Could a Therizinosaurus defeat a T-Rex? Let's imagine a confrontation between these two colossal creatures. If a T-Rex attacked a Therizinosaurus, it would try to use its powerful bite to incapacitate its opponent. The Therizinosaurus, on the other hand, would need to keep its distance, using its claws to deliver quick, deep strikes. If it could strike the eyes or neck of the Tyrannosaurus, it could cause severe damage, perhaps even fatal. However, if the T-Rex managed to grab it, a single bite from its jaws would be enough to crush bones and end the fight quickly. Another important factor to consider is behavior. The T-Rex was an active predator accustomed to hunting large prey, while the Therizinosaurus likely avoided confrontations whenever possible. If the Therizinosaurus sensed the presence of a T-Rex, its first reaction might be to flee, relying on its height to detect threats in time. However, if cornered, it would not hesitate to use its claws as a last resort. When compared to modern animals, we can draw some parallels. A lion, for example, has natural advantages over an antelope. But if the antelope has long, sharp horns, a single successful strike can seriously injure the predator. The same principle would apply to a confrontation between a T-Rex and a Therizinosaurus. The Tyrannosaurus would have the advantage in most scenarios, but it would not be invulnerable. Imagine one day finding a complete skeleton of this feathered giant. With every piece of its structure finally revealed, we could recreate its appearance with accuracy, determine its mode of locomotion, and even better understand its relationship with other dinosaurs. Science still has a long way to go to unravel all the mysteries of the Therizinosaurus, but each new discovery brings us a little closer to the truth. And so the legend of the Therizinosaurus continues to grow. With each new discovery, it becomes more than just a fossil. It becomes an icon of evolution, adaptation, and the impressive diversity of the dinosaur kingdom. Dilophosaurus. Hollywood films are known for exaggerating details to create dramatic effects, and dinosaurs have always been targets of these distorted portrayals. In many cinematic productions, these prehistoric giants were depicted with sizes and abilities far beyond reality.
What's your story?
However, there is a surprising exception to this trend: the Dilophosaurus. Unlike the reduced and fictional version shown in the iconic Jurassic Park, this dinosaur was even more terrifying in real life. Dominating the top of the food chain in the early Jurassic, it was a formidable predator and the largest of its ecosystem. Although the Dilophosaurus became globally famous only after Jurassic Park, its existence had been known to paleontologists since the 1940s. The first fossils were found in the Kayenta Formation in Arizona, and they included 3 specimens of different sizes. Among them was a nearly complete skeleton, an extremely valuable find at the time. However, the science of paleontology was still developing, and many dinosaurs were misidentified. Initially, the Dilophosaurus was mistaken for a new species of Megalosaurus, another large Jurassic theropod. This classification remained unquestioned for nearly 20 years, until a new, even better preserved fossil revealed a unique feature, a double bony crest on top of the skull. With this discovery, it became clear that it did not belong to the Megalosauridae group. It was reclassified as Dilophosaurus, meaning lizard with two crests, and became the most notable member of its new family, the Dilophosauridae. Unlike the small creature seen in the films, which was shrunk to avoid resemblance to the velociraptor, the real Dilophosaurus was gigantic by the standards of its time. Fossils indicate that it reached 23 feet in length and weighed about 880 pounds, comparable to the weight of a brown bear. Despite its imposing size, it had a lighter skeletal structure and an agile body, characteristics that made it an efficient and fast predator. During the early Jurassic, it was not only the largest predator in North America, but also completely dominated its environment. Unfortunately, the cinematic version ended up minimizing its real importance and impact on the prehistoric ecosystem. In Jurassic Park, in addition to reducing its size, the producers gave the Dilophosaurus a non-existent feature, an expandable collar, similar to that of modern frilled lizards. However, there is no scientific evidence that this dinosaur had such a structure. On the other hand, its double bony crest was a real and intriguing feature. Despite being fragile and thin, these crests probably had important functions. Initially, some scientists believed they helped with thermal regulation, but more recent research suggests that their primary role was in visual communication and sexual selection, helping individuals recognize each other and attract mates. The hypothesis that these crests were used as weapons in fights against rivals or to attack prey was discarded. Their bony structure was too fragile to withstand impacts. If the Dilophosaurus's crests didn't serve an offensive function, its colossal jaws fulfilled this role with mastery. Its skull was large, measuring about 10% of its total body length, which provided an ideal space for its approximately 30 sharp teeth. These teeth were long, curved and serrated, with over 70 small cutting blades on each tooth, allowing for precise and lethal cuts. This adaptation made the Dilophosaurus an extremely dangerous predator. It could tear large chunks of flesh with ease, driving its prey to exhaustion and death by blood loss. Hunter or opportunist? The debate about its diet. For many years, scientists tried to understand how the Dilophosaurus fed. The presence of an unusual opening in the skull led them to initially believe its bite was weak, giving rise to the hypothesis that it might have been a scavenger, feeding on carcasses rather than actively hunting. This theory also supported the idea that it could have been a fisher, similar to the Spinosauridae and the modern gavial. However, More recent research revealed that the Dilophosaurus's cranial structure was robust and resilient, allowing it to apply enough force to hold live prey and fight against other predators. Additionally, its large size suggests it hunted large herbivores, not just small animals or fish. As a result, paleontologists now believe that the Dilophosaurus was one of the first super predators of the Jurassic, using speed, powerful jaws, and serrated teeth to capture and tear apart its prey. The real image of the Dilophosaurus is much more impressive than the one seen in the films. Instead of a small predator with a fictional collar, it was an agile giant with lethal teeth and one of the most efficient bites of its time. Carnotaurus. In the heart of the age of dinosaurs, long before the first humans stepped on Earth, a unique predator dominated the plains of South America. Its name, Carnotaurus. With surprising speed, a unique body structure, and a set of threatening horns above its eyes, this Cretaceous monster was a true anomaly among the carnivores of its time. The first signs of the Carnotaurus's existence emerged in 1984, when Argentine paleontologist José Bonaparte made an impressive discovery in Patagonia. Hidden beneath layers of rock for millions of years, a nearly complete skeleton emerged, revealing secrets from a forgotten era. The creature measured about 26 feet in length and weighed more than 2,200 pounds, but what really caught attention were its forelimbs. Small, atrophied, much smaller than those of any other predator of its size. If the arms of the Tyrannosaurus rex were already a subject of astonishment, those of the Carnotaurus were close to absurd. However, the Carnotaurus didn't need robust upper limbs. Its true weapon lay in its head. With a short and deep skull, this predator had a lethal bite. Unlike other theropods, its jaw was incredibly light, allowing quick and precise movements when attacking. And then, there were the horns. Unlike any other large predator known, the Carnotaurus possessed two bony projections above its eyes, giving it a threatening appearance and perhaps an advantage in territorial battles. But how did it hunt? Was it an unrelenting pursuer like a Jurassic cheetah, or a deadly ambusher attacking from surprise? Recent studies suggest that the Carnotaurus could reach incredible speeds for a dinosaur of its size. Its long, muscular legs indicate a natural runner, capable of chasing prey in open areas with extreme effectiveness. Additionally, its tail had a reinforced bony structure, allowing perfect balance at high speeds. Every detail of its anatomy seemed designed for one purpose: to hunt and kill. In the Cretaceous ecosystem, the Carnotaurus coexisted with an impressive diversity of creatures. Among its likely prey were large sauropods, herbivorous dinosaurs that roamed in herds. To bring down one of these giants, the predator would need strategy and precision. Some scientists suggest that the Carnotaurus may have used its robust head as an impact weapon, striking its victims with brutal force. This hypothesis is further supported by the analysis of its powerful neck muscles, which ensured stability and resistance during confrontations. Although it wasn't the largest carnivore of the time, it had advantages that made it a formidable competitor against other giants, like the Giganotosaurus and the Mapusaurus. In the environments where it lived, the Carnotaurus may have had to compete with larger predators for food. Instead of facing these giants directly, it might have adopted an opportunistic strategy, hunting smaller prey or even scavenging carcasses left by larger predators. Its speed was a significant advantage in this approach, allowing it to quickly flee if a larger competitor appeared. Cretaceous South America was not only home to colossal predators, but also equally impressive herbivores. The Carnotaurus shared its environment with immense sauropods like the Argentinosaurus, one of the largest land animals to ever exist. However, prey of that size was beyond the reach of this agile predator. Its preferred targets were smaller, more agile and more vulnerable animals like the iguanodonts and ornithopods that roamed the dense fields of the region. But not every battle was against other predators. The Cretaceous climate changes, variations in vegetation, and the availability of prey also shaped competition between species. Those that couldn't adapt were wiped out. The Carnotaurus survived in a constantly changing world, refining its skills to remain at the top of the food chain. But if this predator was so lethal, why did it disappear? Like so many other colossal creatures of its time, the Carnotaurus met its end at the close of the Cretaceous period, when a series of catastrophic events devastated life on Earth. A colossal asteroid impacted the planet, releasing energy equivalent to billions of atomic bombs. Dust and debris covered the sky, blocking sunlight and triggering a global winter. Without food, and in an increasingly hostile environment, the Carnotaurus and many other dinosaurs perished. Today, the legacy of the Carnotaurus lives on in its fossilized remains and in our representations of prehistoric life. Its skeleton is a testament to the impressive evolutionary diversity of dinosaurs and the brutality of a world that existed long before us. With its speed, sharp jaws, and threatening horns, the Carnotaurus was undoubtedly one of the most formidable predators that ever walked the Earth. And so, in the shadows of time, the Carnotaurus continues to fascinate us, a ghost from a lost era, a king without a throne, whose name echoes through the ages. But what if, somehow, there was still something more to discover? Buried fossils, traces hidden in places never before explored. Could the Carnotaurus have been even more terrifying than we imagined? Only time and science can reveal the last secrets of this predator from the past. Carcharodontosaurus. In a world long before humanity, where the Earth was dominated by colossal creatures, a massive predator reigned over the vast territories of what we now know as North Africa. Its name? Carcharodontosaurus. This gigantic theropod, whose name means shark-toothed lizard, was one of the most fearsome predators of its time, rivaling in size and ferocity with the largest carnivores that ever walked the Earth. Belonging to the Carcharodontosauridae family, This dinosaur exhibited an impressive combination of strength, speed, and serrated teeth that evoked the image of a terrifying shark from the ocean depths. The Carcharodontosaurus lived during the Cretaceous period, approximately 100 to 93 million years ago. During this time, the continents were constantly shifting, and the region that today forms the Sahara Desert was a lush paradise of rivers, lakes, and dense tropical forests. These conditions provided a perfect environment for the growth of some of the largest dinosaur species that ever existed. And among them, the Carcharodontosaurus was one of the most impressive. Measuring about 39 to 46 feet in length and weighing around 13,200 to 17,600 pounds, this predator rivaled the famous Tyrannosaurus rex in size. However, its anatomical differences indicated a distinct hunting style. Its forelimbs were smaller, though not as reduced as those of the T-Rex, and its jaw, while powerful, did not have the same crushing force. Instead, the Carcharodontosaurus used its enormous serrated teeth to make deep cuts into its prey, allowing them to bleed to death. The teeth of the Carcharodontosaurus were true living blades, measuring up to 8 inches in length. The similarity to shark teeth not only gave it its name, but also played a deadly role in its ecosystem. Unlike predators that crushed bones, like the T-Rex, the Carcharodontosaurus relied on a more strategic approach, rapid attacks and devastating cuts that left its victims exhausted and vulnerable. Fossils of this giant have been found mainly in Africa, in countries like Morocco and Egypt. However, the history of its discovery is filled with twists. The first remains were identified in the early 20th century, but World War II caused a scientific tragedy. The original fossils were destroyed during bombings in Munich. Decades later, new excavations brought other specimens to light, allowing paleontologists to reconstruct its anatomy and confirm its position as one of the largest theropods ever discovered. At that time, the African environment was full of challenges. Winding rivers cut through vast flooded plains, while dense forests hid prey and predators lurking in the shadows. But no factor influenced the competition between carnivores more than the abundance or scarcity of food. The rivalry between these Cretaceous titans was intense and relentless. However, it was not just the battles that determined one predator's dominance over another. Hunting strategies, physical endurance, and even intelligence played a crucial role. The Carcharodontosaurus, for example, may have been an opportunistic predator, using its sense of smell to locate carcasses and avoid unnecessary confrontations. This tactic would allow it to conserve energy for successful ambushes and precise attacks. The coexistence of the Carcharodontosaurus with other gigantic dinosaurs suggests an ecosystem of intense competition. Among its contemporaries was the Spinosaurus, an even larger semi-aquatic dinosaur that likely competed for territory and prey in the same swampy and riverine habitats. This interaction between two colossal predators fuels one of the greatest questions in paleontology. Did the Carcharodontosaurus and Spinosaurus face off in epic battles, or did each dominate a specific ecological niche, avoiding direct conflict? Despite its imposing size, the Carcharodontosaurus was not the only formidable predator of its time. Giant crocodiles such as Sarcosuchus and smaller yet agile dinosaurs composed a true survival of the fittest scenario. Additionally, some of its potential prey were gigantic. Herbivorous dinosaurs like Paralitodon and Uranosaurus needed strategies to escape the grasp of this relentless hunter. Recent studies suggest that the Carcharodontosaurus may have been an opportunistic hunter, attacking both juvenile dinosaurs and sick or weakened individuals. Analysis of the biomechanics of its skull suggests that it did not have a bite as crushing as the T. Rex's, but its hunting strategy was based on repeating lethal bites, using its serrated teeth to cause large lacerations. But the age of giants was coming to an end. Climate and geological changes at the close of the Cretaceous began to alter ecosystems, making life for these colossi increasingly difficult. As the seas rose and habitats transformed, the great predators began to disappear, paving the way for a new dominance on planet Earth. The disappearance of the Carcharodontosaurus marked the end of an era of titans. Today, the remnants of this super predator tell us a fascinating story about life and the struggle for survival in a world lost to time. Excavations continue to reveal new information, and with each discovery, scientists are getting closer to the truth about this incredible dinosaur. The legacy of the Carcharodontosaurus lives on, not only in the fossils we find, but also in our imagination. After all, who has never wondered what it would be like to come face to face with one of the largest predators in Earth's history? A monster with shark-like teeth, eyes fixed on its prey, and a roar capable of shaking the ground beneath its feet. Luckily, we can only imagine. For in its time, the Carcharodontosaurus was undoubtedly the true king of its prehistoric jungle. But what if there is more to discover? New excavations in the Sahara could reveal still hidden secrets. New fossils may indicate unknown habits, revealing that this giant could have been even more terrifying than we imagined. Science is just beginning to unveil the mysteries of this super predator. And in the meantime, the legend of the Carcharodontosaurus continues to grow, like a haunting shadow in Earth's distant past. Baryonyx. Time rewinds, as if the universe's tape is being rewound. Millions of years slip away in seconds, and the world we know disappears. In place of concrete cities, primeval forests and wild rivers dominate the landscape. We are in the early Cretaceous period, approximately 130 million years ago, an era where dinosaurs reign supreme. Among the giants that roam these fertile lands, there is a singular predator. Its name is Baryonyx, and its story begins to be revealed little by little, like a fossil puzzle excavated with meticulous precision. Its name means heavy claw, a direct reference to its deadliest weapon, an immense curved claw on the first finger of its hands, sharp as a natural blade. An elongated and slender skull, it doesn't resemble the fierce tyrannosaurs or the cunning velociraptors. Its face more closely resembles that of a modern crocodile, with a snout full of conical teeth, perfect for grabbing slippery prey. Experts believe this creature had a highly specialized diet, being one of the first known dinosaurs to feed predominantly on fish. Imagine a raging river, its murky waters hiding whole schools of prehistoric fish. The Baryonyx approaches the shore, its eyes scanning the surface. It moves cautiously, its robust skin glistening under the hot Cretaceous sun. Then, in a swift and precise motion, it plunges its claw into the water and, in an instant, catches a large fish that struggles uselessly in its serrated jaws. The discovery of the Baryonyx occurred in 1983, when a young fossil hunter named William Walker found a huge claw bone in the southeast of England. The find astonished paleontologists. Until then, no carnivorous dinosaur of this size was known in the region. As excavations progressed, a nearly complete skeleton emerged, one of the best preserved theropod skeletons from this period. The bones told an impressive story. The Baryonyx had a muscular neck, adapted to withstand the impacts of aquatic strikes. Its hind legs were powerful, but not built for the frantic running of land predators. Everything indicated that it was a specialist, an expert fisherman of ancient times. Evidence found alongside the fossils confirmed this theory. Inside the Baryonyx's stomach cavity, fossilized fish remains were found, along with bones from small dinosaurs. This suggests that despite its preference for aquatic prey, it didn't refuse the opportunity to feed on other animals when necessary. But how did it hunt? Was its fishing technique similar to modern brown bears, which capture salmon in raging rivers? Or did it have an even more sophisticated strategy, waiting patiently until its prey approached close enough for a lightning-fast attack? The shape of its skull suggests it could partially submerge its head in the water without compromising its breathing, a trick similar to modern crocodiles. In addition to its ecological role as a predator of rivers and lakes, the Baryonyx is also part of an intriguing group of dinosaurs called Spinosauridae. Close relatives like Spinosaurus and Suchomimus share similar traits, suggesting a peculiar evolutionary niche for these semi-aquatic hunters. Some researchers believe they represented a primitive form of transition between the world of terrestrial dinosaurs and the realm of marine reptiles. The Spinosaurids, over the course of evolution, exhibited a fascinating adaptation to semi-aquatic life. The Spinosaurus, the largest among them, had a massive dorsal sail whose functions are still debated. But the Baryonyx, smaller and more agile, likely relied on its dexterity and brute strength to ensure its survival. This difference suggests that, while some Spinosaurids evolved to become more efficient swimmers, the Baryonyx maintained a hunting strategy more geared toward ambushes at the river's edge. Recent evidence indicates that the Baryonyx's habitat wasn't limited to rivers and lakes alone. Fossilized footprints suggest that it may have also explored flooded plains and even prehistoric mangrove regions. This raises intriguing questions. Was the Baryonyx an opportunistic predator, adapting to different ecosystems according to the seasons? Or did its diet vary depending on the availability of prey in each environment? But life in the Cretaceous was unforgiving. Larger predators lurked in search of opportunities. The baryonyx, despite its imposing nature, was not the undisputed lord of its territory. Large carnivores like Neovenator could pose a real threat, forcing it to move away from the best hunting areas. Additionally, environmental changes could affect its main food source, forcing it to constantly adapt. And then, like all non-avian dinosaurs, the baryonyx met its end. Whether due to climate changes, competition for resources, or the great extinction that swept the planet at the end of the Cretaceous, it disappeared, leaving only fragments of its existence to be discovered millions of years later. But its story was not lost. Each fossil found, each study published, each new theory formulated helps us rebuild a world where it reigned by the banks of ancient rivers. Today, its legacy lives on in museums, documentaries, and the imagination of those who dare to look into the past and glimpse a time when colossal creatures ruled the earth. The baryonyx, with its lethal claw and unique adaptation to the aquatic environment, is a powerful reminder of the diversity and complexity of prehistoric life. A singular predator, a fossil enigma, a giant of the Cretaceous rivers. Mapusaurus. The Mapusaurus was one of the most impressive predators to ever inhabit the Earth. This carnivorous dinosaur belongs to the Carcharodontosauridae family, a group of large theropods that dominated the southern hemisphere during the Cretaceous period. Its name, Mapusaurus, means lizard of the land, referring to the word Mapu, which comes from the Mapuche language, a native people of Patagonia, where its fossils were found. The first fossils of this colossal predator were discovered in Argentina in 1997 during an expedition led by paleontologists Rodolfo Coria and Philip Curry. The excavation took place in the famous Huincul Formation in the Neuquén province, an area rich in dinosaur fossils. The evidence suggests that the Mapusaurus lived approximately 97 million years ago in the late Cretaceous period. The Mapusaurus was a gigantic dinosaur, comparable in size to the famous Giganotosaurus. It is estimated to have reached between 33 to 39 feet in length, with some hypotheses suggesting that the largest specimens could exceed 42 feet. Its weight ranged from 6.6 to 11 tons, making it one of the largest predators of its time. Its skull was long and robust, with serrated teeth that were perfectly adapted to cut through the flesh of its prey. Additionally, it had a lightweight skeletal structure, which allowed it to move with agility despite its colossal size. Fossil evidence of the Mapusaurus is remarkable for a rare feature among large theropods. Multiple individuals were found at the same location. This led scientists to speculate that these dinosaurs may have lived in groups, an intriguing hypothesis for a large predator. This discovery raises the possibility that the Mapusaurus might have hunted cooperatively, something previously not associated with large theropods. If the Mapusaurus did indeed hunt in groups, this would give it a significant advantage when hunting giant prey, such as the titanosaurs like Argentinosaurus, one of the largest herbivorous dinosaurs to ever exist. Pack hunting behavior would allow these predators to work together to isolate weaker or younger individuals, increasing their chances of success in predation. Such behavior would also indicate a level of social organization more advanced than expected for large prehistoric carnivores. Analysis of the bones found revealed that the Mapusaurus had relatively fast growth, suggesting a high metabolism similar to other large theropods. Its skeletal structure indicates that it was an agile runner for its size, capable of efficiently chasing prey. However, it likely did not rely solely on speed, but also on strategy and strength to overpower its victims. Its bite force, though less powerful than that of a Tyrannosaurus rex, was sufficient to inflict fatal wounds in just a few attacks. The teeth of the Mapusaurus, although not as long as those of the Tyrannosaurus rex, were extremely sharp and adapted for cutting meat. Unlike the T-Rex, which had a crushing bite, the Mapusaurus and other Carcharodontosaurs used a biting technique based on multiple cutting bites, causing massive bleeding and weakening their prey until they succumbed to shock and blood loss. This biting technique resembles that used by certain modern sharks, which tear apart their prey rather than crushing it with brute force. Reconstructing its environment shows that the Mapusaurus lived in an ecosystem full of large herbivores, including several titanosaurs, which served as an abundant food source for the large carnivores of the time. The region's climate was hot and semi-arid, with seasonal periods of rain. The vegetation was mostly composed of conifers, ferns, and other plants that dominated Cretaceous ecosystems. There was also a large diversity of smaller dinosaurs and flying reptiles that shared the territory with the imposing predators. The Mapusaurus, like other large theropods, faced challenges both in hunting and survival. It likely competed for territory and food with other predators, such as Megaraptor and Giganotosaurus, which also inhabited South America at the same time. Fossilized broken teeth found near skeletons suggest that these confrontations could have been frequent, and only the strongest and most strategic survived. Despite its impressive presence in the food chain, the Mapusaurus, like all non-avian dinosaurs, met its end during the Cretaceous-Paleogene mass extinction event about 66 million years ago. However, its discovery and study continue to provide valuable insights into the evolution and behavior of large prehistoric predators. Research on this dinosaur continues, and new discoveries may bring even more information about its biology and behavior. Based on fossil analyses, scientists continue to debate aspects of the behavior and biology of this impressive theropod. Many questions remain unanswered about how it interacted with other dinosaurs, what its social hierarchy was like if it lived in groups, and what its most effective hunting strategies were. But one thing is certain: the Mapusaurus was one of the largest and most fearsome carnivores that ever walked the earth, and its story continues to fascinate paleontologists and dinosaur enthusiasts around the world. Furthermore, modern technologies are allowing more detailed reconstructions of its way of life. With the use of tomography on fossils and 3D modeling, paleontologists are gaining a better understanding of the musculature and even the locomotor habits of this predator. These new scientific approaches make the study of the Mapusaurus even more exciting, revealing previously unknown aspects of its anatomy and ecology. In the future, with new discoveries and technological advances, we may gain even more accurate insight into the impact of this colossal predator on the Cretaceous fauna.